Today we're going to be talking about our first chapter in our trig unit. So we're starting in chapter 4, and we're going to be reviewing a lot of our basic trig things first, like angles, degrees, radians, our right triangle trig. Most of this stuff we should have seen in geometry. However, it's been a little bit, so we're going to review kind of like we're all trying to get on the same page. So today we're going to go over our trig basics. So first, let's get a few definitions. So, an angle. So in general, an angle is going to be the distance between two rays connected at both initial points. So remember that when we are talking about an angle, the vertex is what we call that point where they connect. The initial side is going to be our starting side. And our terminal side is the ending. And your angle is going to be that distance between those two sides. Now, coterminal angles are going to be two angles that share the same terminal side. So one example of this would be if we have an angle and our first angle goes that direction, so the higher ray is going to be our terminal side. Then if we were to go the opposite direction, that would give us a coterminal angle. I'm using thetas here to represent my angles because usually we're going to use Greek letters to represent any of our angles. And in general, in order for us to know if or where to put our angles, we want to put them in standard position. That way we know that whenever I'm talking about a 30-degree angle, I know that I'm going to draw it the same way that you would draw it if you were going to draw a 30-degree angle. So we're going to just always draw things in standard position. And the way that that works is the initial side of an angle lies on the positive x-axis. The vertex is at the origin. And the angle is measured going counter clockwise. So let's look at what that might look like. So I have my axes in my coordinate plane. We said that my vertex is going to lie at the origin, and my initial side is always going to be on that positive x-axis. And then our terminal side is going to depend upon what angle we're actually trying to draw. And remember that we do want to go counterclockwise, so we go to the left from our initial side. Also, just a good reminder, whenever we're talking about angles, for this one, I would say that my terminal side is in my second quadrant. So remember that our upper right-hand corner is going to be our first quadrant, and then we go counterclockwise. So this would be quadrant 2 in the upper left-hand corner. In the bottom left-hand corner would be quadrant 3, and in the bottom right-hand corner would be quadrant 4. And that's going to be a good way to describe which area of our coordinate plane that we're in, is just to say my terminal side is in quadrant 3, and then I know which space or area we're talking about. Okay. So our directions tell us to find an angle with a positive measure and an angle with a negative measure that are co-terminal angles. Well, first thing it might help is to just draw our angle. So hopefully we can recall that a right angle is going to be 90 degrees. And that a straight line is going to be 180 degrees. So we know that since our initial side of our angle has to be on the positive x-axis, we know that if we were to go to the positive y-axis, that would be 90 degrees. And we know that if we were to go all the way to the negative x-axis, that would be 180 degrees. So we know that our angle is going to be partway in between that second quadrant. And so that would be our theta of 130 degrees. However, notice that we said that in order to find a coterminal angle, one of the easiest ways is, instead of going clockwise, counterclockwise, we would go clockwise. So basically finding this other portion. Now hopefully we also recall from geometry that a full circle rotation would be 360 degrees. So if I have a portion, the light blue portion is theta, and we know that theta is 130, and we want to know what that missing portion is. We could take 130 degrees, and we're going to subtract that from 360. And so we would get 230 degrees. The problem, however, is if I were to leave that positive, we would still be going counterclockwise. And notice that if we were to go counterclockwise 230 degrees, we would not end up in our second quadrant. So the way that we indicate that we're going to go clockwise instead is by making it negative. So we actually want to take 130 and subtract 360. Now, it says that we need one negative. Well, we've got that. The other thing that we need now is a positive angle. That's a coterminal angle. Well, notice that there's not another way for me to end up at the same place in that first 360 degrees. But remember that in general, we can always continue to go around our circle. So even if I start at the same spot, if I were to go all the way around one time and then back to that same ending spot, that's still going to be a coterminal angle. So we still end up at the same spot, but basically what we've done is we've taken 130 degrees and we've added 360 degrees, or added a full rotation, which gets us 490 degrees. So in general, we can always add or subtract 360 in order to find a coterminal angle. Alright, so next up we have radians. So y'all are very used to degrees for your measurement. However, when I'm talking about measurements, degree is a unit. And when we're talking about rotations, especially when we start looking at applications, sometimes units and unit conversions can get in the way. And so that's why somebody came up with this idea of a radian, because it doesn't have a unit attached to it. It's kind of called what's called a pure unit or a pure measurement, because there's not actually a unit attached to it, because we actually use the circle to look at that. So radians are the measure of an angle that intercepts an arc equal in length to the radius. So here I have a circle. The center of my circle would be here, assuming that those lines are actually perpendicular, which mine's slightly off, but that's okay, we can imagine. So notice that this first line would be my radius. And so basically what we're saying is, if I were to take that radius, so say we put a piece of string, the length of that radius, and we then laid that string along the outside of the circle, that arc length, basically, or the curved length, is going to be the same distance as our radius. And that is going to equal 1 radian. And notice that if we were to continue with that pattern, this would be 1 radian, and then 2 radians would be slightly into our second quadrant. Then we would have 3 radians, 4, 5, 6, and we would actually have a little bit left over. And the reason for that is because if we talk about the circumference of a circle, remember that we're talking about 2 pi r. Well, let's just say that we're just going to let our radius be 1. So our circumference would be 2 pi. And the reason that we can do that is because if we were to solve for the radius for any circle, because like I said, it's that pure measurement, it ends up reducing out. So when I'm talking about radians in general, if we were to go all the way around, it is 2 pi. Well, notice that if I take 2 pi, so pi we can approximate to be 3.14, and we multiply that by 2, we get 6.28, which is why I said that we would be able to take that radius arc length around the outside 6 times with a little left over. Now hopefully we can notice that if going all the way around my circle is 2 pi, going halfway around my circle would just be 1 pi. And then going half of that would give us pi over 2. So in general, if we need to convert between degrees and radians, we have a nice conversion rate. Because when we multiply, remember that we want to reduce whatever we have. We need whatever we have to be on the bottom. So if I have degrees, I want to multiply by pi radians over 180. If I have radians, I want to multiply by 180 over pi. And the relationship that we're using is that pi radians equals 180 degrees. So let's look at a few conversions. So notice that here we're starting with 100, or we're starting with degrees on all of these. So I know that I want to multiply by pi over 180 degrees, because when we do that, our degrees are going to reduce, which is what we want. So we're just going to end up with radians. And then we're just going to have a fraction. So notice that we would have 135 pi over 180. Well, 135 and 180 can both be reduced. So we would reduce that to 3/4. So simplifying that, we would have 3 pi over 4, which means that we have 3/4 of a pi, or of a radian. So in our next one, it's going to be the same process. I start with degrees, so that means that I want to multiply by pi over 180 degrees. So again, our degrees are going to reduce. So notice this time 180 actually goes into 543 times. So we end up with 3 pi. Now please be careful, because 3 pi is different than just saying 3 radians. Because remember, we said that 2 pi is equivalent to that 6.28. So that's 6 and a little bit more radians. So here I have 3 pi radians. So in order to figure out the actual number of radians, you would need to multiply 3 by 3.14. So just be careful with that distinction, that 3 radians is different than 3 pi radians. And our last one is negative, but the process is still going to be the same. I'm going to take negative 270 degrees, multiply that by pi over 180 degrees. My degrees are going to reduce. And notice that 270 and 180 is going to reduce to 3/2. We didn't do anything to the negative, so it's going to stay the same. So we would have negative 3 pi over 2. We can also go the opposite direction. So this time, instead of multiplying by the pi over 180, this time we want to reduce the radian, so we want the pi to be in our denominator. So we would take our negative pi over 2 radians. We're going to multiply by 180 degrees over pi. Notice that our pi's are going to reduce. And then we just need to reduce our leftover numbers. So notice that 2 goes into itself 1 time, and into 180 90 times. Again, we didn't do anything to that negative, so it stays the same. So we have negative 90 degrees. Next, again, we're taking 9 pi over 2, and we're going to multiply by 180 degrees divided by pi. Our pi's are going to reduce. Again, 2 goes into 180 90 times, but I still have a 9 there, so we would need to take 9 times 90, which is going to give us 810 degrees. Now on this last one, I have 2 radians. I don't have a pi, and this is where I said it's careful that 2 pi would be 360 degrees, but because we don't have a pi, we're not actually talking about 360 degrees. because we can't reduce that pi. So we would take 2 times 180, which does give us 360 degrees, but then because our pi didn't reduce out, we still have that divided by pi. And if we were to approximate that, we would get 114.59 degrees. So 2 radians is approximately 114.59 degrees, which is different than saying 360 degrees. So just be careful and make sure you check if there is that pi there or not.